Okay, students. So we'll move on to the next question. Question number 8. Obtain a DFA to accept strings of zeros and ones having 3 consecutive zeros. Right? So in previous 7 questions, we were facing the alphabets A and B, but now we got 0 and 1 exactly. Okay, both are same. Sigma will be 0, 1 instead of A, B. Okay. So what he's trying to mention the condition here is the string must have 3 consecutive zeros. Okay. 3 consecutive zeros means what? Continuous 3 zeros. Okay. If any string consisting of 3 consecutive zeros followed by any number of ones, does not matter. Okay. So then it should be accepted. Fine. So here, what is the minimum string? We got minimum string will be 3 zeros, right? Okay, 3 consecutive zeros we are representing. So the minimum string will be what? 3 zeros. Okay, so the length of the minimum string is what? Equal to 3. Fine. So 3 plus 1, total 4. Okay, so total 4 states we need to represent this particular condition using DFA. Yeah. Okay. So now the minimum string is what? Continuous 3 zeros. So we'll deal with this first. So the first state will be Q0. Okay, the start state. And second one, Q1. Then later Q2. And the fourth one, Q3. Okay, so Q0, I will make it as a start state, right? Okay, so the first 0, okay, whenever we get this first 0, then Q0 will change its state from Q0 to Q1. Okay, then later Q1 on receiving the second 0, it will change its state from Q1 to Q2. Okay, then later Q2 to Q3. Third 0 will be accepted by Q2 and it will change its state from Q2 to Q3 exactly. Okay, so now if this minimum string is accepted by this DFA, then what I need to do? I need to make Q3 as a final state, right? Q3 as a final state. Then obviously this minimum string 000 will be accepted. Okay, so this is what the basic version of this DFA. Now we'll go for another string pattern. Okay, like 11 000 if you have. Okay, see in our question they had mentioned only condition that string must have 3 consecutive zeros. Okay, apart from that, wherever we want 1 we can use. Okay, so pre also and post also. Okay, like before this 3 consecutive zeros also we may be having any number of 1. Okay, or any number of 1-0 combination also. Okay, does not matter. But somewhere in the string we must have 3 consecutive zeros. Okay, if this is the case also possible, then 101 000 101. If this is the case, this is also possible. Then 101 01 000 if we have, this is also possible. And also one more variety, 000 1101. Okay, if this is the case, it is also accepted by this particular DFA. Okay, so now we are finding the transition only for 0. Okay, now we need to find the transition for 1 also. Okay, so now if these 3 consecutive zeros, okay, before this, if we are having any number of 1, it should be also accepted, right? In this condition, observe it carefully. Okay, 11 000 we are having. Okay, if this is the case, it should be accepted by this particular DFA. So what we need to do for Q0, okay, we need to decide what will be the transition for input alphabet 1. Okay, so if I provide a self loop of 1, okay, if I provide a self loop of 1 for Q0, okay, then before this consecutive zeros, if we have any number of 1, then it will be accepted. Clear? Okay. Now, one more variety we'll observe. Okay, if we are having, okay, so this is what over, fine, like 11 000 over. Then at last, if you are finding continuous 1, okay, then what we can do? In the final state, we can provide a self loop of 1, okay, and also we can provide it for 0. Why? See, if a number is beginning with any number of 1 followed by 3 consecutive 0 and ending with a combination of 1 0 or ending with a consecutive 1 or ending with a consecutive 0, does not matter. Okay. So this will be the DFA which is accepting this variety of question. Yeah, this variety of question. Fine. Like starting with any number of 1 followed by 3 consecutive 0 and later again followed by 3 consecutive 1 or any number of 1 exactly. This is how like n number of 1 followed by 3 zeros and again followed by n number of 1 exactly. Okay. 1 comma 0 why we are providing. Okay. There may be a combination like this, like 1 0 1. Here 1 0 1. Initially also we have, last also we are having. Okay. Forget about this. We'll deal with this later. Okay. Now, after finding 3 consecutive zeros, if you are having a combination of 1 and 0, any number of 1 and 0 it may be, okay, then it will hold it. Q3 with 0 comma 1 or 1 comma 0, okay, if you provide it as a self loop, you will be remaining in final state itself. Okay, so this variety can be accepted. Now, what about this kind, like 1 0 1 if we have? Okay, when we get the first one, we will be remaining in Q0. Later we have a 0, will be coming for Q1. Okay, so now the input value is what? 1 exactly, right? Do we have any transition for 1 inside Q1 and Q2? We don't have. Okay, but for Q0 and Q3, we got all the possible transition for 0 and 1. Observe it. Okay, now we need to decide what will be the transition for Q1 on receiving 1. Okay, so as I mentioned in fourth or fifth question, so this is what the track, okay, which is moving towards the final state. Okay, so you will be in this particular track whenever we are getting 3 consecutive zeros, then only. Okay, so now observe it. If this is what the input, first one input is what? 1 exactly. So you'll be in Q0. Second is what? 0, right? So we feel that when we get 0, we feel that, okay, there may be a consecutive zeros, 3 consecutive zeros. So we begin our travel from Q0 to Q1 towards the final state. But now, when you are in Q1, we are receiving the input 1 exactly. Okay, means this is not a version of consecutive zeros. Then what we need to do? We need to send that 1 to such a location, okay, from where we may begin with the consecutive zeros over there. So what we need to do, if we are having 1 in this particular position, then it should be shifted to Q1. It should be shifted to Q1. Okay, means you are starting from Q0. Observe it. You received 1, you will be in Q0. You are receiving 0, you are going to Q1. Now, again in Q1, you are receiving 1 exactly. So you are coming back to Q0. Okay, so from here, if consecutive zeros occur, then you will begin your travel in this particular path. Is it right? Okay, so now in this particular condition, just observe 1 0 1 we are having 1 0 1. Later what you have? 3 consecutive zeros you are having 0 0 0. Later 1 0 1 we have. So this will be accepted by this particular DFA. Clear? Okay. Then later this particular combination, what it is? 1 0 1 0 1. Again you are getting 0 1, right? Okay. So this will become like a loop exactly. Okay. Like we are not entering for Q2, I guess. Okay, you will be remaining in Q1 itself because see here, 1, see I'm taking this example. Okay, so 1, 0, 1, okay, 0, 1 exactly. Okay, so this is what example which will be accepted by this DFA, but we are not entering for Q2 with input alphabet 1 exactly. So let me change this example bit, okay, so that we can decide what should be the transition from Q2 on receiving 1 exactly. Okay, so now 1 0 1 0 0 1 0 0 0 if we have. Okay, we'll go through this particular example now. 1 0 0 1 0 0 0. Yes, it should be accepted by this particular DFA, right? Because it is having 3 consecutive zeros. Now, 1 0 0. Okay, you are in which state? Q2 exactly. What is the next input? Next input is 1 exactly. Okay, so now what I should do with this transition for 1? Okay, see, if I provide a self loop, then obviously this will become wrong. Okay, because like in between. Okay, if you are getting like 1001 double, okay, 10010, then it will be accepted by this particular DFA, right? Here 10010 exactly. That should not happen. Okay, so whenever we receive 1 in Q2, it also be sent to Q0, so that later if we can get consecutive zeros, we can start our journey from Q0 to Q3 exactly. So instead of providing a self loop for Q2 on receiving 1, it should be transferred to Q0 itself. Okay, so now for this particular input, observe it, 100. So you are in Q2 state. What is the input alphabet? 1 exactly. So 1 when I get, okay, we are changing our state from Q2 to Q0 again. Later, if you are having 001, sorry, 000, then Q0 to Q1, Q1 to Q2, Q2 to Q3 exactly. Okay, so this particular skeleton is holding good for all the varieties of possible 3 consecutive zeros. Okay, when our input strings are, or as input alphabets are 0, 1. Okay, if you want, you can try for any other version of input string with 3 consecutive zeros, or like any other, like which it is not compulsory, like you need to check only for acceptance case. Okay, you need to check for rejection cases also. Yeah. Okay, for this DFA also, I'm not going to mention the delta function over here. Okay, because total 4 different states are available, 4 into 2. Okay, 8 delta function I need to write over here. Okay, instead of that, I'm writing the transition table. Okay, so you can start writing your transition function. Okay, individually. Okay, now m will be equal to, as usual, q comma sigma comma delta comma q naught comma f, right? Okay, so q will be equal to what? Q will be equal to q naught comma q1 comma q2 and later q3, right? Okay, then sigma will be equal to, be careful, 0 comma 1 it is. Okay, then delta function you write by your own. Fine, so q naught is the start. Okay, is the start state, and f is what? The final state. What is the final state? Q3. F will be equal to Q3 exactly. Now we'll go for drawing the transition table for these 4 states. Okay, so 0 and 1. Okay, 0 and 1. So Q naught. So this should be a delta. Q naught is the start state. Okay, then later Q1, later Q2, then Q3 exactly. So Q naught on receiving 0, Q1 it will be, right? Q naught on receiving 1 will be Q naught itself. Then Q1 on receiving 0, Q2 it will be. Q1 on receiving 1, again Q naught it will be. Then later Q2 on receiving 0, it will be Q3. Okay, Q2 on receiving 1, it will be Q naught, right? Okay, then Q3 on receiving 1 and 0, or 1 or 0, it will be remaining in Q3 itself. Okay, so you may ask, like, instead of providing a self loop of 1 for this Q3, can we provide this transition for Q0? No, actually it is wrong. Because see here, when you are going to reach this Q3, after traveling 0, 0, 0, means 3 consecutive 0, after overcoming 3 consecutive zeros, then only you are able to reach the Q3 over here. Okay, so what is the condition? Like 3 consecutive 0 is must. Okay, how many times it is occurring? Once or twice, does not matter. Okay, if once also occurring, you are entering for the final state, and later, whatever may be the number of ones or 0 or combination of 1 and 0 you will get, you will be in final state itself. Because the condition what we are expecting, it is already satisfied over here. Okay, so this is what the solution for your question of 3 consecutive zeros. Okay, okay, students. So we'll meet with next problem.